As we change the scale of a map, it might be necessary to generalize the map, or specifically features on the map, such as individual layers, in order to allow all of that information to fit within a smaller area on the map. We can break this down into a lot of different categories, and one of the ways we can do this is by changing the content of what is actually on the map or the geometry of what is actually on the map. We could also obviously change the symbols or the layers. We could use smaller symbols or put less labels on the map, but the two we're going to concentrate on here are the content and the geometry, so we can see some examples of what this sort of map generalization would look like. Let's start with the content. If we want to make our map simpler, some things we can do is we can eliminate features, we can reclassify features but keep them on the map, or we could reorder things so that they show up in a different order. Let's look at eliminate. Let's say we want to take a map like this and show it in a smaller area on a piece of paper or on a web page. Although all of these individual streets look fine at this scale of mapping, they start to look very cramped at this scale. So we can just take off the minor streets and just leave the major streets on this map. That would be an example of eliminating certain features or content so that we can have a more generalized map. Another way we can do it is we can reclassify. In this example here, we have a stream going through some terrain, and the terrain is broken up into a series of classes, with each change in color representing a different elevation here. It might start looking cluttered when we go to when we put it on within a smaller area at a different scale, but we can just not put as many classes on. Instead of having 1, 2, 3, 4, 5, 6 different classes here, we can go down to half as many classes or 3 classes. So another way to do it besides content is by geometry, and this is any manipulation of the points, lines, and polygons on the map in order to make it look more generalized or simpler. And here's some examples of what we can do. Sometimes we can actually put things together and aggregate them, or we can do any of these other steps in order to make a more generalized map. Here's an example where we have a series of mines within a map, and if we're zoomed in enough, it's fine to show that as a series of cross picks, such as in this example here. But when we start zooming in, or when we start generalizing this, when we show this map in a smaller area, the picks are overlapping now. It doesn't look as good. So maybe instead we just put a polygon on here to show that all of those, there's an area of mining here. We're not just trying to show where individual mines are, but in this way we've kind of aggregated all these points into these 2 different areas. This would be an example of collapse, and that's when we go from something like a polygon down to a point. In this example here, we have a capital that's right on a river. It looks good at this scale. At this scale, it starts looking very cramped. So instead of trying to represent that as a polygon, we just represent it as a point and make sure it's clearly indicated that that's a capital. That would be an example of collapse. Sometimes though, even though we're trying to generalize our map, sometimes it's important to show prominent features in a way that looks good on a map. So in this example here, Cape Cod looks good at this scale of mapping, but when we put it within a smaller area, we map it at a different scale. Now it's all very skinny, and the line is touching itself in more places. It doesn't look as good, but we can exaggerate that if we want to. It's not actually, and it's not, this outline is not actually properly showing exactly where Cape Cod is, but it's not meant to. Someone's not using this for driving or any purpose like that, but we do want to show the form of Cape Cod on this map. That would be an example of exaggerating. One thing we can do is simplify. So this is nice because at a scale like this, we want to see all the detail on the island of Sicily and Italy here. But as we put the same map into a smaller area, as we change scales here, now this looks very jagged and may not be very visually appealing, or just not necessary to show that level of detail at this scale of mapping. So instead we just get rid of some of the points that show this outline. So the operations simplify, basically just get rid of points. And there's a famous algorithm for this called the Douglas-Poiker algorithm. And here's how it works. Let's say we have a line that looks like this, and we want to simplify it by getting rid of some of these vertices. We have a start node and an end node and some vertices in between. What we can do is just draw a line from the start node to the end node, as is shown in A here. And then we see what the greatest distance is from our new line to another node, which in this case is, or another vertice, which is in this case vertice C here. And if that distance is below some kind of tolerance that we've decided to use, then we add an extra line. So now instead of going from here to here, we go from here down to here and then over to here. Now we go along the line again, find where our greatest distance is, which is in this case here. That distance is still above the tolerance. So now we put another vertice in here. So now we go from here to here to here and then to our endpoint. Again, we find our greatest distance. Again, this is a greater distance than the tolerance. So we put in another point here. But by the time we get to this point here, all the remaining points here are a lesser distance away than the tolerance that we're using, so we can just get rid of those points. So this would be an example, this blue line shown here would be an example of a simplified version of this line here. And another thing we can do, which is sort of like simplify, but it's smoothing. So we would take a rough line and make it look more smooth, because this rough line looks very rough at this scale of mapping here, but we can just kind of smooth it out and get rid of all those variations.